Page 20 of Complex Numbers and Polynomials bookwork. Today we're going to talk about quartic polynomials. Quartic polynomials means a polynomial that has a fourth degree coefficient to start with, okay, and then goes on down the line. Let's see. First we're going to talk about a square factor where the graph touches the x-axis at alpha. We're talking about a quadratic here, right? It's got a 2 there. We're going to work up to a fourth degree square factor or quadruple factor. So first I'm going to draw the square factor. It's a parabola and it touches at x equals alpha. It touches once at x equals alpha. It's a double root, so it goes and touches and it comes back. It doesn't cross, okay? Let's look at cubed factor. A cubed factor touches once at alpha, but a cubic, touches and then it goes down. So it's got an inflection point right on the x-axis. It says it's flat at alpha because it's a stationary inflection point. Last of all, we got a quadruple factor, which touches once at alpha. And in this case, it comes down, it touches here, and is flat, and it goes back up. So it kind of looks like a parabola, doesn't it? But the difference is the curvature at this point is also 0. Whereas remember, the curvature for the parabola is always positive because it opens up throughout the whole length of it. If you made a sign diagram for the quadruple factor, you would see that the second derivative of the function at the vertex is going to be 0, and then it is concave up in both of the other sections. So it's kind of a strange parabola that gets very flat in the center. Okay, but that's kind of a specific rare quadruple factor. I mean, most of the time you're not going to have the same factor 4 times. You're going to have 4 different factors maybe. So let's look at different types of quartics. Quartics can look in general like camel humps, look like a W. Because in general, quartics change direction 3 times. 1, 2, 3. You get it? Okay. So let's take a look at a few quartics and let's try to write the equation for the quartics. Remember that every time a quartic touches and comes off the x-axis, that is a double root. So here it looks like we have a double root at -1, and we also have a double root at +1. Okay, and then of course we have a multiplier at the beginning, a, and let me rewrite this as x plus 1 squared times x minus 1 squared, and we know that this also gives an additional point which is 0, 2. So we could substitute in 0 for x, and we'll get a times 1 squared times 1 minus, or 0 minus 1 is -1, -1 squared is -1. So basically we have -a equals 2. So a equals -2. Okay, so we got this equation, and a is equal to -2. Let's look at C. In this case, we have one touch on the x-axis, which is 2. So we got a double root at 2. And we cross once at -1, and we cross once at -2. So it's x plus 1 and x plus 2. And we have a multiplier in front, which is a. Let's see how big the multiplier is by putting 0, -16 in here. So we got, oh, by the way, this is, I made this equal to 2 to figure out what a is, remember? Okay. In this case, I am going to set this equal to, I'm going to put zeros in for x, and I'm going to set this equal to -16. So let's try that. So we got a times -2 squared, so that's a times 4. 0 plus 1 is 1. 0 plus 2 is 2, so we have 2 times 4. A equals negative 16, so A is equal to negative 16 divided by 8, which is negative 2. I'm going to shrink this down so we have a little bit more space for our last quartic. Okay. In our last quartic, we have the quartic touching at 1 and 4. And we don't know where else, the other roots may be imaginary. Let's see how many double roots or triple roots we have here. So negative 1, this is a single root because it actually crosses, right? Now remember, if it came down and touched and came off, then we know it's a double root. But in this case, it comes down, it touches, becomes flat, and then it goes the other way. So this, remember, is a triple root, okay? So the triple root is at 4. So actually, all the roots are shown here. So we have x minus negative 1 times x minus 4, and this is a triple root, multiplied times a. So a x plus 1, x plus 1 times x minus 4 cubed is equal to negative 16 if we put 0 in for the x's. So a times 1 times negative 4 cubed, which is negative 64, equals negative 16. So a is equal to 1/4. Checking my answers, I see that I have made a mistake on 1a. Do you see that if I put zeros in here and here, I have 1 squared times negative 1 squared. Negative 1 squared is positive 1, not negative 1. So we have positive a equals 2, and so a is equal to 2. Okay? All right, let's go to 3. Find the equation of the quartic whose graph cuts the x-axis at negative 4 and 1/2 and touches it at 2 and passes through the point 1,5. Okay, so this is kind of a verbal example of the problems that we were just doing with the graphs. So we got a times x minus negative 4 because we have a single root at negative 4, and we have a single root at 1/2. You could write x minus 1/2, or you could put 2x minus 1, either one, and touches it at 2. So touches it at 2 means it touches it and comes back, doesn't cross. So that would be x minus 2 squared. And we could use this point 1,5 to figure out the value for a if we put 1 in for x and we set the whole thing equal to 5. So that would be a times 5, because 4 plus 1 is 5. 1 minus 1/2 is 1/2. 1 minus 2 is negative 1. Negative 1 squared is equal to 5 times 1 times 1/2 is 5/2. A equals 5. So A is equal to 2. Finally, let's do 3C. We're looking for the quartic which cuts the x-axis at plus or minus 1/2 and plus or minus 2 and passes through the point 1, negative 18. So basically this looks like a times x plus 1/2 times x minus 1/2 times x plus 2 times x minus 2, and it goes to the point 1, negative 18. So if we plug in 1 for all the x values and we set it equal to negative 18, we can figure out what x is. So that would be a times 3/2 negative, or 1/2, because x, or 1 minus 1/2 is 1/2. 1 plus 2 is 3, and 1 minus 2 is negative 1. So let's multiply out all the fractions. So that would be, the numerator would be 3 times negative 1, which is negative 9, and the denominator would be 4. So let's multiply both sides by, or let's divide both sides by negative 9. We'll get that, we'll get 2, because negative 18 divided by negative 9 is 2. Multiply both sides by 4, so we get that a is equal to 8.